Hello, my name is Akshay Dongaonkar, and I'm a senior platform engineer at Pangea. Pangea is a collection of APIs that application developers use to secure their application and help drive compliance towards industry standards such as SOC 2. We're a company that is extremely early in our journey, having been active for about 8 months at this time. Therefore, both our platform tech and our APIs are still in a period of rapid iteration, as service authors let me know what features they like, and our product managers let us as an engineering team know what features customers are interested in consuming. And in fact, this talk is about rapid iteration at its core. We'd like to build a system that enables Pangea developers to very easily launch new capabilities globally for consumption by our customers. For a concrete example of a capability that we provide, we have an audit API that lets you store audit logs in a tamper evident manner for a customizable time period. The audit API is backed by our audit service. In this presentation, I'm going to show our platform tech that lets a developer at Pangea create, develop, test, modify, and deploy their service. Each service at Pangea is deployed to a Kubernetes cluster, and all customer data is localized to a particular region. When a customer enables a service or an API for use, they decide where their data will reside. Similarly, our service authors determine in which regions their service will be active. The interface they use, stored at the top level of each service, is via a file called pangea.yaml. Now, after this talk, if somebody has a better name for this file, please let me know. We've been searching for one for a while. Now, let me go ahead and share my screen so that we can provision a new service for this talk. This new service is just going to be a simple geolocation service that lets us query that lets us map an IP address to a country code and show a list of the top 10 countries, or show a list of the top 10 APIs queried so far. So let me go ahead and share my screen. And at this point, let me show you our create service tool. If you take a look at the help text, you'll see that you must provide the name of the service. Now, we're just going to call our service Geo. Uh, you need to say that it's going to be a Kubernetes service, and you need to provide the language for your service. Now, the reason why you provide a language is so that there is a standard way that developers at Pangea will pull third-party dependencies into our pipeline. So for Python, there will be a standard poetry file that where you will add your pip dependencies in order to build your service. So let me go ahead, create a branch, uh, and run the create service tool for our geo service. Now, when this tool is run, it's going to create a bunch of files. And let me just focus on the Terraform for right now. So you'll see that in that output, you'll see that there's a bunch of Terraform files that were created. Now, what that does is one of the three responsibilities of the Pangea.yaml infrastructure, right? Pangea.yaml manages the CI for your service, it manages the Kubernetes objects for your service, and it manages the infrastructure for your service, aka the Terraform files. So, in this particular initial create of our Geo service, really all we're doing is creating Terraform files, and I'll show the Terraform files above. It was in the text editor. Now, what's going on in this merge request is we're just doing a Terraform plan and then eventually getting a cost estimate of what the infrastructure we're provisioning is going to cost. But of the three responsibilities, you tell via pangea.yaml what Terraform you want to create for your service. And by default, each service gets a Kubernetes namespace, a Kubernetes service account, an AWS IAM role, an ECR repository to push resources or to push the Docker file that each service creates into each AWS region, et cetera, et cetera. Now, we're also available on GCP clusters. So when you create a service and say that you need it in GCP, the create service tool will generate Terraform for you that will create a registry in GCP regions as well. But as we can see in this merge request, there's no cost because really all we're doing is creating, a repository and things of that nature. But let's get into what other things you can ask Pangea.yaml for and create our geo service that will map an IP address to a particular country code. So yes, this is the Terraform code that lets you create the repository and whatnot. But let me go ahead and open up the Pangea.yaml here. So for the purposes of this talk, we're only going to deploy to our dev cluster. We're not going to deploy to AWS or GCP, just because this is something we're really not going to ship to customers. Now, the two for our geo service, let's store some state as well, and have a count or a top IP addresses hit endpoint that will allow us to use a database. So let me go ahead and ask Pangea.yaml for a database. And that's this syntax here. Right now, we only support Postgres databases. As you can see via this key here. Since we only have one database, this is going to be our default. This controls what environment variables the database or our deployment is given in order to connect to the database. And this is an interesting key. Essentially, what we're saying here is when a merge request is opened, I want to provision an ephemeral Postgres pod for the lifetime of that merge request only. This is a feature that service authors really like at Pangea because it lets them test their migrations from the empty state, and in the post merge pipeline lets them test their migrations on a semi-full database. And we'll get into additional testing strategies later. Now, to use our geolocation API via the excellent GeoIP2 database, I need to provide an environment variable that it gives me the client secret for that key. And Pangea.yaml provides that functionality. So you can do so via an env key. In this particular case, since this is an actual secret, what we do is we store our secrets in GitLab CI/CD, and we pull it into our deployment via Pangea.yaml. So in this case, the type of this environment variable is GitLab, and we're going to pull it from geolocation key and inject it into the pod as geolocation key. This is a common pattern, but if I say geolocation key foo, it's injected into the pod as geolocation key foo, but it's stored in GitLab as geolocation key. Now, Pangea.yaml has other integrations as well. Specifically, this routes key. This routes key integrates with our API gateway as well as our billing and metering service, so each API can get charged separately. In this particular case for this demo, we're actually just going to expose our service publicly to the world and bypass our API gateway entirely. So in order to do that, I'm just going to set this routes key to an empty list and ask that we just directly expose this container port to the world under the geo subdomain. And this order key is not particularly important. All that means is in the AWS load balancer rule ordering, like just place it at level 150, and the ordering goes from 0 to 1,000, I believe. And the same construct holds true for Google clusters. But actually, I already have a branch up that has done this. So let me go ahead and just switch that branch. Let me just stash this and go to KD implement geo. So you'll see that this is already done. And there was one thing I didn't cover, which is the test framework itself. So at Pangea, the Pangea.yaml machinery also controls how tests are run. So there are three types of tests. There are unit tests, there are integration tests, and there are performance tests. So our unit tests can be a combination of Django unit tests or regular PyTest unit tests. Our integration tests are generally written in PyTest, regardless of the language of the service. And our performance tests are run using a framework called Locust. Now, like I said, Pangea.yaml controls three things: the GitLab pipeline, the Kubernetes objects themselves, and then the Terraform for the service. So this test framework key modifies the GitLab CI pipeline that runs the integration tests. And all these three responsibilities are are managed when I run my configure service tool. So when I configure this service, it's going to generate a bunch of files that implement each of the three responsibilities. So you'll see that for the Kubernetes, for example, since we're exposing the service to the world publicly, uh, the Pangea.yaml infrastructure creates a Kubernetes ingress object, right? Currently, we use sed to kind of template out the deployment on a merge request versus a deployment on the main branch. We're still looking for a better tool. We've messed around with Helm and Customize, but we haven't felt comfortable with switching to those yet. So at the moment, it's plain old sed. Every time a merge request happens, we set out one set of variables, and every time a main deployment or a production deployment happens, we set out a different set of variables. Now, I was speaking about tests, so you'll see that PyTest. So you'll see that in this particular job, this is just a standard GitLab CI YAML that defines a particular job. This particular job only runs on merge requests, and we're just running the integration tests at test/integration. Now there will be a PyTest job in the post merge pipeline as well. But the service author just does not have to worry about this. All they do is just set the test frameworks key, implement their tests. In this particular case, we're hitting our API with a random IP. And this just verifies that your functionality is working end to end. And our Pangea.yaml author can actually specify custom Terraform modules to run, but we're not going to get into that in this talk. Normally, Pangea.yaml authors or service authors at Pangea use it to provide their IAM role additional permissions. So our service, one of our services needs to send email, so there's a Terraform module to give it email permissions, and it gets injected into Pangea.yaml here. Now, my branch already has a merge request open, so let me go ahead and show that off to you guys. One thing I'd like to bring attention to is this hold deployment key. Now, the hold deployment key, when you open your merge request, it will actually pause your deployment for you in order for you to interact with it whenever you need, right? So our service authors say this is very useful to them because they can just now query their particular endpoint just normally. So in this particular case, my branch name is AKD implement geo in the geo service, and this is that API that is using our Postgres database, right? So I can just hit this endpoint and I can verify everything is working just perfectly fine. And in fact, let me show you the deployment itself in our Kubernetes cluster. So let me switch namespaces to our geo namespace and get a list of pods. So as you can see, there's a Postgres pod specifically for our merge quests, and our deployment running in this singular Kubernetes pod. Let me exec into our pod actually, and DB. So you'll see here that the Pangea.yaml machinery has actually injected the DB host for my particular merge request. And as it goes through the different clusters and as the service distributes out to each of the regions that it's configured to go to, these variables will change via the Pangea.yaml machinery, and the service author doesn't have to worry about it. All they care about is that they're connecting to the geo database via this particular environment variable key. So that, in a nutshell, is the Pangea.yaml infrastructure. With it, you can ask for state, you can create custom Terraform modules to add permissions for things you need and whatnot. You can provide secrets to your particular deployment. You can specify that my deployment needs to go to US West 2 or US East 1 or wherever. We have the AWS and GCP keys. You can size your deployment with the CPU and memory keys. You can expose your deployment publicly to the world via this expose key, or to our API gateway via this routes key. And of course, you can test your service with this test frameworks key. And we found that having this functionality combined with hold deployment in our merge request gives us very good visibility that a change we're going to make is going to be correct and be able to be deployed all over the world. And I spoke a little bit about performance tests, but those run in the post merge pipeline and is the last stage before we actually push out to production. Hopefully, you found this talk interesting and it gave you some ideas on how to maybe build your own platform tech. But once again, thank you for coming to my talk.